So we're going to have a look at some more complex ionic bonding examples. Before you do this, you must be sure about some simple ionic bonding, for example sodium chloride. If you're not sure, have a look at that video, otherwise we'll get on with this one here. The interesting thing about the sodium chloride example is that sodium wanted to lose one electron and chlorine wanted to gain one electron. What we're going to do now is have a look at a situation where the metal wants to lose a different number of electrons to the number of electrons the non-metal wants to gain. So the example that we're going to look at is, let's have a look at magnesium and chlorine. If you have a look at the periodic table, magnesium you'll see is in group 2, so it's got 2 electrons in its outer shell. Chlorine, we know from before, is in group 7, so it's got 7 electrons in its outer shell. It's always a good idea to draw your electrons in a slightly different way when you answer a question, and it just helps you figure things out if you get challenged later. So we know that this electron here goes to here. That's absolutely fine, but magnesium has got an extra electron and it doesn't know where to go. Have a think about that for a few minutes. So we know that chlorine has done this. 1, 2, 3, 4, 5, 6, 7, and it's gained, I've drawn those with crosses, ignore that, has gained an electron from magnesium. Chlorine is happy because it's got a full outer shell. Magnesium, however, has lost this electron here, but it's still got one electron here. What does it do? Well, the crucial thing is, if there's plenty of chlorine around, then one electron can go to one atom of chlorine. This electron here can go to another atom of chlorine, and that's exactly what happens. So I'm going to cheat here by doing this. So we get 2 chlorines, one chlorine gaining an electron here, here, this electron goes here, this electron goes here for a different atom, and there it is. So we still get magnesium with no outer shell, and then we get, because it's lost these 2 electrons, and we've got the chlorine here having gained an electron. If you remember, chlorine, when it gains an electron, gets a -1 charge. Same here. And magnesium, when it's lost 2 electrons here, remember it's lost 2 electrons, means it gains a +2 charge. Okay, so you might want to have a review of that. And once you've had a review of that, I'd suggest you just try sketching that out in your own textbook, exercise book. Once you've done that, I'll give you a few more examples to have a go at, and you can check in a few minutes to see if you've got those right. Sorry, one thing I forgot to say is that this actually here, when you see that one magnesium reacts with 2 chlorines, the result of that is that the formula of magnesium chloride is Mg1Cl2. We always pretty much ignore the 1, so we call it Mg2Cl2, and that is the formula of magnesium chloride. We need 1 magnesium and 2 chlorines to make magnesium chloride. Okay, here are the other examples that you need to have a go at, see how you get on with those. So have a go at doing exactly the same kind of layout, calcium reacting with fluorine, so then when you've done that, sodium reacting with sulfur, and aluminium reacting with oxygen. Pause the video, and I'll put the answers on the next slide. And those are your answers. If you haven't done them, haven't done the examples, stop, cover it up, have a go, and check it out. One last thing to talk about is a quick way to work out the formulas of the compounds, of ionic compounds. So this is kind of a cheat way to work out the formula of the ionic compound. I'm going to do the aluminium oxide example, so I don't know the formula of aluminium oxide, but I do happen to know that aluminium is in group 3 and oxygen is in group 6. Anything in group 1 has a charge of +1, Anything in group 2 has a charge of +2. Anything in group 3 has a charge of +3. Similarly, anything in group 7 has a charge of -1. Think about why. Anything in group 6 has a charge of -2. There's the oxygen. Anything in group 5 has a charge of -3. First step is to ignore the signs. So I just write Al3 and O2. I've ignored the plus and the minus. Next step is to swap them over. So the aluminium gets oxygens 2 and the oxygen gets aluminiums 3. Next stage is to drop those numbers down. So aluminium gets the 2, oxygen gets the 3. And the last step is to simplify. In this case there is no simplification. The simplest way of writing it is Al2O3. And if you have a look on the earlier on in the video, you know the formula of aluminium oxide is Al2O3. So this is something you really need to remember, is these steps here. Ignore signs, swap them over, drop them down and simplify. Ignore signs, swap them over, drop them down and simplify. Once you get that practiced, you'll be very, very confident in writing the formula of ionic compounds.